In this video, we'll be talking about the multiplication of matrices. This is an important concept in our journey in matrices because it has several applications, one of which you use in vectors, which is an important topic if you're taking physics or you're a student taking physics as a course. Now, before we can talk about multiplication of matrices, in an earlier video, we talked about the scalar multiplication. That is what happens when we want to multiply a matrix with a number. So we looked at how to do that. Also, we talked about the addition and subtraction of matrices, how we subtract, how we add matrices. And then we said the condition must be satisfied before that will be possible. Before you can carry out addition or subtraction, the order of the matrices or the two matrices must be equal or the same. For multiplication, it's quite different. So let's say we have two matrices, A and B. Before we can multiply A and B together, we must make sure that the number of column in matrix A equals the number of row in matrix B. Now remember, if the number of column in A is not equal to the number of row in B, then this matrix A and B can't be multiplied together. They are simply not compatible. For them to be compatible, the number of column in A must be equal to the number of row in B. But that's not all. Remember, when you add two matrices together, when you subtract two matrices from each other, they maintain their order. For multiplication, it's quite different. Multiplication will have a different order, especially if you're not multiplying two matrices with the same dimension. That it is the same dimension, definitely they will maintain their order. But if you're multiplying two matrices that have different dimension, then the first matrix or the resulting matrix rather, will be of the row of the first matrix times the column of the second matrix. But when we take an example, we'll talk more about that. But remember, the most important thing is that for two matrices to be multiplied together, they must be compatible. And compatibility means the number of columns in the first matrix must be equal to the number of rows in the second matrix. Remember, unlike addition, where we said A plus B for matrix now, A plus B is the same thing as B plus A. For matrices, A dot B doesn't necessarily mean A dot B doesn't necessarily mean B dot A, or A cross B rather, A times B is not necessarily equal to B times A. It will be equal if they are square matrix. Equal in the sense that they are equal matrix rather. So if I'm multiplying a matrix, maybe I'm taking its square. So the order doesn't matter. So I'll have the same answer and also the same order. But for other types of multiplication, A times B would not always be equal to B times A. So let's take our first example and see what we mean by that, or how to find or check for compatibility of matrices. So let's say we're given matrix A equal to 1, 2, 5, and 6. Okay. And matrix B equal to 3, 4, 7, and 8. Now, before I can find A times B, I must make sure they are compatible first. That is, the column of the first matrix A must be equal to the row in the second matrix B. Now, what's the order of this matrix? The order of this matrix is simply a 2 by 2 matrix, while this also a 2 by 2 matrix. So since they are 2 by 2 same square matrix, then definitely they'll have the same, or they'll be compatible rather. So, but remember, A times B would necessarily must be equal to B times A. So let's just use this to to find out whether A times B is the same thing as B times A. All right. So aside that, the second thing we said is the resulting matrix will now carry the row of the first one, which is 2, and then the column of the second one, which is 2. So that means after multiplying A times B, my resulting matrix should also be in the form 2 by 2. So let's see what we want to do. Now, when you're carrying out your multiplication, you multiply the first row, this row you're seeing here, with the first column of the second one. That is, multiply this first row with the second column, or with the first column rather. Multiply this first row also with the second column. Multiply this second row with the first column, multiply the second row with the second column. So that's what we want to do during the course of our multiplication. So what do we do? So we simply take a big bracket. So this becomes 1 times 3, this one times 3, then plus 2 times 7, 2 times 7, and I'm done with the first member or first element in my resulting matrix. Now take the same first row, and multiply it with the second column. So in such a way that I have 1 times 4 plus 2 times 8. So do the same thing for the second one. So 5 times 3 plus 3 plus 6 dot 7, and then I have 5.4 plus 6.8. Okay, now simplify this. 1 times 3 is 3, 2 times 7 is 14, and 14 plus 3 is 17. So again, move on to the next one. I have 2 times 8, which is 10. Then 4 times 1 is 4, so I have 14 here. Okay, so 2 times 8 is 16, brother, not 10. 2 times 8 is 16, okay, so that will be 20. Okay, so 5 times 3, that's 15. 6 times 7, that's 42. So add them together, that should be 57. Okay, and then 5 times 4, 20. 6 times 8, that's 48. Add them together, so we'll be having 68. All right, so this is the answer I'm having. But remember, we said A times B not always mean B times A. So quickly, let's just do B times A somewhere here. So just at the side without cleaning or wiping away the answer to A times B. Okay. All right, so B times A. So again, before we can multiply B times A, we have to ensure that they're compatible. Number of column in the first one, so what's the number of column? 2 must be equal to the number of row in the second one, so 2 by 2, and then as the other 2 by 2 also after multiplying. So what do I do? 3 times 4 multiplied by 1 times 5. So we have 3 times 1, 3 times 1, that will be 3, plus 4 times 5, so that's 20. Okay, 3, 4 times 2 and 6, so 3 times 2, that's 6, and 4 times 6, that's 24. Okay, okay, what do I have again? So I'm done with this first one, so let's move to the second one. 7, 8, and 1, 5. So 7 times 1, we have 7, plus 8 times 5, that's 40. Then lastly, 7 times 2, that's 14, and then 8 times 6, that's 48. Okay, by the time we had this together, so my resulting matrix, 3 plus 20, that's 23. 6 plus 24, that's 30. This is 47. And 14 plus 48 should be 62. Okay. All right. So you can say this is my A times B, and then this is my B times A. So they're not equal. So remember, for multiplication, multiplication is not commutative in matrices. So especially when you're not dealing with equal matrix. All right. So let's try and look at other examples. So this time around, you guys are going to be pausing the video just to check for compatibility first and see how to multiply matrices together, so we can call it a day on this topic. So remember that the application of this mostly comes underneath vectors. So you've taken vectors at one point in time, especially vectors in 3 dimensions, where you talk about the cross products of vectors. So you see that you also be applying your knowledge on matrices. Okay, so let's look at another one. So let's say another example. So let's say we are given matrix A to be equal to 5, 4, 2, and matrix B is equal to 4 and 5. So at these matrices, can you find A times B? Are they compatible? So remember, we said for a matrix or for two matrices to be compatible, in order to carry out multiplication, the number of column for the first one must be equal to the number of row of the second one. So if we were to write the order of this matrix, so this matrix has 3 rows and 1 column. So this is a 3 by 1 matrix. Why this one is a 1 by 2 matrix, 1 row and 2 column. So let's try and say, like this matrix here, are they compatible? So remember we said number of columns of the first one, so which is 1. Number of rows of the second one, also what? Also 1. So since this is true, then definitely they can be multiplied together. So they can be multiplied together. And what type of matrix are we going to be forming? This is simply going to be forming A. So we pick the row of the first one. So the matrix are resulting matrix A cross B. We have the order 3 by 2 matrix. So 3 and then the column 2. So these two matrices result in a 3 by 2 type of matrix. So quickly, let's see how we multiply this said matrix. So since it's a 3 by 2 matrix, so we want to do your box like this. Okay, so what do we have? So we take the first row, column, first row again, another column. So yeah, I'm having 5 times 4. So 5 times 4 gives me 20. So 5 times 5 gives me 25. Okay, now move on to the next number. 4 times 4, that's 16. 4 times 5, that's 20. And then lastly, 2 times 4, 8. And 2 times 5, that's 10. So you can see the dimension of this is a 3 by 2 matrix. So first we check for compatibility. Now after checking for compatibility, you want to know the resulting order. So you can work your way towards that. All right, so let me give you one more example, and then we can call it a day. Matrices. Okay, so one more example. So what if I given this matrix of this order? Let's say I'm given 2, 3, 5, 1, 4, 6, 0, 7, and then we have to multiply this matrix with 3, 4, 2, 9. Okay, so can we multiply these two matrices together? So let's say this is matrix A and then this is matrix B. So are they compatible? So what's the order of this matrix? So this matrix has 2 rows and 4 columns. So this is 2 by 4 columns, 2 by 4 matrix rather. Why this matrix has 1, 2, 3, 4, 4 rows? So this is a 4 by 1 matrix. So you can see that the number of columns of the first matrix is 4, while the number of rows of the second matrix is also 4. So hence they are compatible. And what type of matrix are we going to be getting? We'll simply be getting a 2 by 1 matrix. So A times B will give us a 2 by 1 matrix. So, okay, so 1 column and then 2 rows. So let me make this okay. So that's what we have. All right, so quickly, so what do we do? So we just do 2 times 3 plus 3 times 4 plus 5 times 2 plus 1 times 9. So that will give us the first row. So I'll repeat myself. 2 times 3 plus 3 times 4 plus 5 times 2 plus 1 times 9. So let's just get our calculator and do everything once. So 2 times 3 plus 3 times 4 plus 5 times 2 plus 1 times 9. So we are having a total of 37. And for the second row, multiply it with the first column also. So here we have 4 times 3 plus 6 times 4 plus 0 times 2 plus 7 times 9. So here we're having 99. So you can see what's the order of this matrix? Also a 2 by 1 matrix. So this is how we multiply matrices together. So quite simple but tricky. So you just check for compatibility and then you carry out your multiplication while determining the order of the resulting matrix. So in our next video, we'll be looking at how to find the determinant of a matrix. So do well to like the video if it has been helpful so far. Also share the video and subscribe to the channel. Thank you and bye-bye.